take the first one out, but I did not replace it back in, right? So what is the probability I'm gonna take, what is the probability that I'm gonna take the second one out? We'll take the first one out, there's 9 left, right? So the probability the second one, to take the second one out will be 1 out of 9, right? So we take the second one out. What about the third? Well, 1/8, right? Because there's 8 balls left in there. And then on and on, right? So as you see, without replacement, the probability change for each time you take out a marble, right? So for without replacement, it's not independent because the probability change. So it's here you can say, oops, 2. Probability change, maybe I'll use red. Changes throughout. So therefore is not independent. It's not independent, right? What about with replacement? What about you take the marble out, but with replacement? Move this up a little bit. So now with replacement, right? Same thing, you have a bag of marble, 10 of them in there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? Take one out. Take the first one out, right? Still, so 110. But because you do with replacement, you put it back in and then you take the second one out, right? So because you put it back in, there's still 10 marbles in the bag, right? So the second one being taken out is still 1/10, and because the replacement, you put the second one back in, right? So still 1/10 when you do the third one, and so on, right? So the probabilities does not change. With replacement, the probability does not change throughout, therefore is independent, right? So this one we can conclude that the probability does not change. Prob doesn't change. Therefore imply independent. Right. So what do you think? So now that you know that without replacement, it is not independent, and with replacement, it is independent. So let's get back to our problem. 4 students, and then you have a large sample size, which is 1,000 juniors and 1,000 seniors. You want to pick 4 out of those 2,000. Now, what do you think? Is it without replacement or with replacement here? No, right? This is without replacement. So certainly it is not independent, right? Because you pick the first one out, and then because the first one will be 1 out of 2,000 chance, 1 out of 2,000 chance to get one of the first to select a student, right? But then as soon as you take that student out, you only left what? 1,999, right? So 1 out of 1,999. So that's the probability the second one changes. And then it's the same thing with the third and the fourth, right? So it changes throughout. So therefore it is not independent. Nope, not independent, right? So we got a bad one there. Now, I know that is, as soon as you got a bad one, you can stop and you say it is not binomial distribution. But I'm gonna work throughout. Okay, I'm gonna work throughout all the way to the fourth one, which is what? Do we have a same probability throughout? Of course not, right? Because it's not independent. So probability is not the same. It changed. As soon as you pick one out, it changed. Probably is not. It's the same throughout the process. Right, throughout the process. Therefore, it is not independent. independent. I'm sorry. Therefore, it's not binomial distribution, right? However, do you guys remember the rule of thumb? I highlight in green, right? If the sample size is less than 5% of the population size, then it is okay. So let's see, what is the percentage of a sample size here? We have 4, the sample is 4 out of what, 2,000, right? So we write in green here, 4 out of 2,000. Definitely less than 5%. 4 divided by 2,000 is 0.002. So that's 0.02%. Right? Sorry, 0.2%. I'm sorry, 0.2%. That's 0.2%. Well, definitely less than 5%. So it is okay because of rule of thumb, because of the rule of thumb. Right, the sample size is what does it say? Sample size is less than 5% of the population size. Okay, so even though we have 2 failing things here, we have 2 out of 4 is not satisfy the condition. But however, because the population size, the population is so large, 2,000 versus 4, the sample size, right? So large, it is okay to say that this problem has had a binomial distribution.